Hello friends, myself R.D. Mahajan presenting my video on solution of difference equation by Z transform technique. Let us solve the problem. Given difference equation is f of n plus 2 plus 3 times f of n plus 1 plus 2 times f of n is equals to 0, and the conditions are f of 0 is equal to 0 and f of 1 is equals to 1, and therefore applying the procedure here, given difference equation is f of n plus 2 plus 3 times f of n plus 1 plus 2 f of n is equals to 0. The next step is taking Z transform on both sides, left hand side as well as right hand side. Therefore, Z transform of f of n plus 2 plus 3 times Z transform of f of n plus 1 plus 2 times Z transform of f of n, and that is equals to 0. Z transform of 0 is 0. And then applying the standard result, Z transform of f of n plus 2 is z square f bar of z minus z square f of 0 and minus z f of 1. This is the Z transform of the first term. Then Z transform of f of n plus 1 3 times. Z transform of f of n plus 1 is z f bar of z minus z f of 0 and plus 2 times Z transform of f of n is f bar of z, and that is equals to 0. Then collecting the terms of f bar of z, there are 1, 2 and 3 terms. In the separate bracket we get z square plus 3z and plus 2, and common is f bar of z, and that is equals to substituting the values of f of 0 and f of 1 and then transferring to right hand side, we get the value of f of 0 is 0, therefore this term becomes 0. Value of f of 1 is 1, therefore minus z. If you transfer on right hand side, it becomes plus z. Once again f of 0 is 0, that term becomes 0. And then we get the value of f bar of z as z divided by z square plus 3z plus 2. We try to find the factors of this denominator term. Factors are 2 and 1, product is 2 and sum is 3, and therefore z upon z plus 2 into z plus 1. Product gives you z square, 2z plus z we get 3z, and 2 into 1 we get 2, and we call this as equation 1. Here the half part is over. By finding Z transform we get this equation number 1. Then we have to apply inverse Z transform technique to find the value of f of n. For that, the first step is multiply both sides by z raised to n minus 1. Therefore we get z raised to n minus 1 into f bar of z is equals to z raised to n minus 1 into this term z upon z plus 2 and z plus 1, and nothing but taking a product of these two terms of z, that product is z raised to n minus 1 plus 1, we get z raised to n, and divided by z plus 2 and z plus 1. Okay, we call this equation 2. Equating the terms in denominator, from denominator to 0, we get z is equals to minus 2 and z is equals to minus 1, as these are two simple pole. Simple pole means the power of these terms are 1. That's why these are simple pole. And next step is we try to find out residue at the first pole and residue at the second pole by applying the technique. Then first residue, that is residue at z is equals to minus 2, by the formula, as it is simple pole, it is z minus a, here it is z minus 2, z plus 2, z minus a is minus 2, therefore minus minus become plus 2, multiplied by this term, that term is z raised to n divided by z plus 2 into z plus 1 at z is equals to minus 2. So that this z plus 2 get cancelled and the remaining terms are z raised to n divided by z plus 1 at z is equals to minus 2. And therefore substituting the value as z is equal to minus 2, we get minus 2 raised to n divided by minus 2 plus 1. Minus 2 plus 1, we get that value as minus 1. And we call this as equation number 3. That is the first residue. Then second residue, residue at z is equal to minus 1. Again applying the formula, same formula, z minus a, z minus minus, it becomes z plus 1, multiplied by this term, that term is z raised to n divided by z plus 2 into z plus 1 at z is equals to minus 1. This time z plus 1 get cancelled. Remaining terms are z raised to n divided by z plus 2 at z is equals to minus 1. And then substituting the value, this one is minus 1 raised to n and minus 1 plus 2, we get plus 1. And we call this as equation number 4. And then the required solution is sum of these two residues. Therefore, f of n is equals to sum of the residues. And therefore it is equals to, I will write on the first one as a positive term, and therefore that term is minus 1 raised to n. Then second one with minus sign, therefore minus 2 raised to n is the required solution. Is the required solution or required answer. Therefore, whenever we have to solve any difference equation by Z transform technique, there are two parts. In the first part, we try to apply Z transform technique to obtain that f bar of Z, and after getting f bar of Z, we try to apply inverse Z transform technique by residue to find f of n, and f of n is nothing but the sum of the residues. Therefore, for this particular example, we get the answer as minus 1 raised to n minus 2 raised to n. Therefore, so far I have discussed 3 different problems how to obtain the solution of difference equation by applying Z transform technique. One more I will discuss in my next video. Please like my video, share it, as well as subscribe to my channel if you are not subscribed yet. And to receive the notification for my such type of new videos, press the bell icon. Thank you. Thanks for watching.